Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll solve a problem on unit quantities. Basically, in the unit quantities, three parameters is to calculate. One is unit speed, and another is unit discharge, another one is unit power. So in our last lecture also, we have discussed the theory part regarding this unit quantities. Based on that concept, I have taken this problem. So the problem is given here. A Pelton wheel is revolving at a speed of 190 rpm and develops 5150.25 kilowatt when working under a head of 220 meter with an overall efficiency of 80%. Determine unit speed, unit discharge and unit power. The speed ratio for the turbine is given as 0.47. Find the speed, discharge and power when this turbine is working under a head of 140 meter. So first two things we need to do here. First of all, we need to calculate the unit speed, unit discharge, unit power from this value. After that, we need to calculate the normal like speed, discharge, power for different head. So in our last lecture, we have discussed this similar kind of concept and we have derived some formulas. So based on that formula, we'll solve this problem. So first of all, let's write down the data given, which is given in the question. In the solution, we can write what are the data given here. So first thing in the first line itself, we can see the speed of the Pelton wheel is given. That is nothing but we can write this is speed N1 I can write here, that is 190 rpm. And the second one is given here. It develops the power. So power is given P1. P1 is given 5150.25 kilowatt. Yeah, when working under a head of 220 meter. So H1 is given 220 meter. And the next is overall efficiency of this is given. So eta naught is given, this is 80%, or I can write this is 0.8. So here we need to calculate three things. One is unit speed, unit discharge and unit power. After that, it is given that the speed ratio for the turbine is given by 0.47. So we can write this is speed ratio is given 0.47. And the next one, find speed, discharge and power for when the turbine is working under a head of, so here we can write H2 is given 140 meter. So we know the formula last time we have seen last lecture that for what is the formula for unit speed. So unit speed is denoted by NU, and NU is the the formula for this is N1 divided by root over of H1. Similarly, unit discharge. So discharge unit is like key U, it is denoted by key U. So here also the formula is same thing, just Q1 and divided by root over of H1. So this root over of H1 is common for both the things. The next one is unit power. So that is nothing but PU. So PU will be calculated similarly for this also, P1 divided by root over of, here not root over, here we need to consider H to the power 3 by 2. So H in the sense that is H1 to the power 3 by 2. So these are the formula what we have derived in our last lecture for unit speed, discharge and power. So here if you see in the first one, the data is given already in the question. That means N1 is given, that is nothing but 190 and divided by this is 220. So this one we can calculate. Similarly, yeah, Q is not given here and power is given. So we can write this is power 5150.25 and divided by H1 is how much? This is 220 to the power 3 by 2. So we can calculate. Now here one more thing, if you see Q is not given. So to find out Q, here overall efficiency is given. So from that we need to calculate the Q discharge value. So anyway, let's first calculate what are the data are given. Let's based on that, let's solve this. So I can write this is 220 root over how much? This is 14.83. So 190 divided by this is 14.83 2.83. So here also the same thing I can write. This is root over of 220. This is Q1 and this is 14.83. Q1 value how much is there we can put and we can find out the value. So let's write this. And one more terminology is there, that is nothing but 220 root over of like to the power bracket start 3 by 2 bracket close 3263. So this one we can write here like 5150.25 divided by this is how much 3263. 3263 point, here we can write 1617 is there, yeah 127, so you can write here 13. Okay, now to calculate this value of Q1, what I'll do here, we know that as I told you that yeah, efficiency is given, so overall efficiency is given. So overall efficiency we can write the power developed P, the power developed by water power, or we can write soft power by water power. So P equal to P value already given. So W water power we can write the formula like rho G QH by 1000 here. Now if you see this equation, our value overall efficiency is given 0.8. Just put this value. Power is given here 51. This is 50.25. Similarly here this rho 1000 and this 1000, let cancel it. Then here we can write this is 9.81 and this is Q value and this is H. H is given how much? This is 220. So here we can calculate the value of Q. So I'll take this Q here and remaining value I'll put it here like 5150.25 divided by this is 9.81 into 0.8 into 220. So we'll find out the value of here Q1. Okay, here I can write this is Q1 H1, Q1 H1 here P1. So this value we can mention it so that we'll get the value of Q1 here. So let's solve this problem. Now if you see in the numerator it is there 5150.25 and divided by bracket start, we can write this is 9.81 multiply 0.8 multiply 220 bracket close. You can find out this is 2.98. So the discharge here we got here 2.98 meter cube per second. The unit is for this. Now here we will put the value of same thing. This is 9.28 divided by this one. Now we can calculate all these unit quantities. So one by one we'll solve it. Like first one, this is 190 divided by 14.83, 12.81. So first one we got here, this is 12.81 RPM. Okay, and the second one is like I'll multiply this with respect to 190 and no, not like that. Okay, leave it. So we'll do one thing, 2.98 divided by 14.83. This is 0.200. This is very small. Anyway, what value we got, we can write 2009. So I can write this is 0.201 meter cube per second. This is unit discharge. Similarly, our unit power also like we can calculate. This is 5150.25 divided by 3263.13, 1.578. So this is 1.578. This is kilowatt. So these are the first initial answer for the first conditions. The second condition is given. These are the answer. This is one, and this is another one. So the questions, if it is given of 6 or 8 marks, so this 3 marks is covered here. Again, next 3 marks will be covered for this one. If it is given some 10 marks is there, then we need to go for step by step, then these formulas, then will be calculated. Now the second step is given when the turbine is working under a head of 140 meter, this one, when H2 is 140, then for that we need to calculate speed, discharge and power. So for that we know formula like N1 by root over of H1, this one equal to, this is for single one turbine, like one head and one turbine. Another head is given means we can write this is same thing like N2 root over of here H2. Here I can write what I need to calculate here. I need to calculate the speed. Okay, only speed we need to calculate. So speed I can write here like second speed is like N2. If I want to calculate N2, so I can write N1 and this is root over of H2 by root over of H1. So I can write this is root over of H2 by H1. I can write in this way. Similarly for the discharge also I can write the same formula like Q1 by root over of H1 and this is Q2 divided by root over of H2, and in the same way I can write this is Q2 equal to here it is Q1 and this is root over of H2 by H1. Okay, similarly I can write for the power, we can write P1 by H to the power 3 by 2 and this is P2 divided by H to the power here H1 here H2 is 3 by 2. So we need the value of power for the second head. So P2 equal to, I can write P1 to the like into this is H2 to the power H2 by H1 whole to the power, we can write this is 3 by 2. So these are things we need to now calculate it. Just we put the value of here N1 equal to how much, this is given 190 and this is root over of H2 how much 140 and H1 given 220. Similarly here also Q1 value is nothing but this is 2.98 and this is same thing like 140 divided by 220. Here also like power already given, power value is 5.50.25 and here we can write H2 140 divided by 220 to the power 3 by 2. So let's solve it one by one so that we can calculate here. So what I'll do 140 divided by 220. This is the first one 0.6363. Okay, 0.6363 root over. So 0.797. So let multiply 190. So 151 point. So here we got 151.56. 151 point. Let's write 57, 56 something was there. This much RPM. The next one. I'll just divide 190 and just multiply 2.98, 2.377. Okay, so here I got 2.377. This is meter cube per second. The last one is power. So power is here, we no need to take this one, like 140 divided by 220 to the power bracket start 3 divided by 2 bracket close, yeah, multiply 5150.25 2614.48. This is kilowatt. So these are the second step answer for the second head. Okay, so in this problem what we came to know that if turbine is given, same turbine is given, but that need to be installed in the different heads, for that also we can able to calculate the speed, the discharge, the power. So that's why the unit quantity is very important to understand or to find out or to optimize for an engineer, like how to install or where to install it, what head, how much discharge will come, how much power is required, or what is the speed of the turbine will be. So all the things can be calculated from this concept, unit quantities. So I hope you understand this problem, how to solve it. If you're having any doubt and query regarding this, you can give a comment on the comment box. Thank you.